recording now, and I'll share the screen. And go, just like usual. Okay, so I think I'm done with what I was going to say. So you can either unmute yourself or put in the chat. And I think the most efficient way is to say test 1, test 2, test 3, test 4, test 5, question, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever. And then we can review that way. There's no new material. So when you stop, I stop. That can be as short as right away if nobody has questions, or it can be the entire time. If we ask questions the entire time, I'm okay either way. Okay, so either unmute yourself or put in the chat whatever you want me to do for review, but no questions and answers on Thursday. So again, right on Thursday, just before class 5:38-ish, I will send you Canvas announcements, the exam, then you can just go ahead and get started and work the entire time on the final exam. Okay, so any questions, please, on anything, any exam? I think I can open the chat here. So yeah, I'll move the chat box over here and take a look here. Okay. Okay, first test, 5, 8, 9, and 10. Okay, yeah, I guess maybe it's more efficient if I go test by test, and some of you are doing that anyway. Okay, so exam 1, 5, 8, 9, and 10 seem to be asked for. Okay, so when I go like this, I'll write it like this, the test number and the problem number. Okay, test 1, number 5. Write the equation in line that passes through the points 1, -3, and 5, 19. I'll quickly show it to you in case you don't have it. If I'm going too fast, it's on the video, so you can always check it later. Okay, so 1, -3, 5, 19. Find the equation. Okay, so first I need to find the slope. So formula for the slope is y2 minus y1 divided by x2 minus x1. Okay, so in this case, it's 19 minus a -3 over 5 minus 1. That comes out to be 22 over 4 or 11 over 2. All right, so now that I have that, I use the point slope form. Point slope form is y minus y1 equals m times x minus x1. I already know the slope. Which point do I pick? You can pick either point. I'll pick this one because they're both positive. So I'll pick this as x1, y1. You could also pick this one. So y minus 19 equals 11 over 2 parentheses x minus 5. And now I just clean that up. Y minus 19 equals 11 over 2x minus 55 over 2. Add 19 to both sides, plus 19, which is 19 over 1. Common denominator is 2, so times 2 times 2. So y equals 11 over 2x. Negative 55 plus 38 is minus 17 over 2. So final answer, y equals 11 over 2x minus 17 over 2, it looks like. Okay. And let's see. Number 3 was asked for also from the first test. Question 3.
Mr. Holmes.
Yes.
On that problem you were just doing, where m equals m, that first x there has nothing to do with the x1, x2, right?
This x right here?
If you go up 1, 2, 3 steps, yes, right there. Y1, yeah. That first x in the parentheses has nothing to do with the original problem, right?
Well, you need that for the equation of the line, which is what the problem asks for. Okay, so your final answer is going to have an x and a y, but x1 and y1 are specific numbers, okay, like 5 and 19.
Right. So that x there is not x1 or x2.
Correct. X is just a variable here, and y is a variable. X1 and y1 technically aren't variables; they're actual numbers, which are 5 and 19 in this particular case. It looks like.
Okay. Thank you.
All right. Welcome. Number 3, solve for x here. Okay, so it's on the video, so I know I might be going fast, and you should already have the test there, but I'm writing it also. 3 over x minus 4 equals 2x over x plus 1. Okay. So common denominator is x times x plus 1. X times x plus 1. X times x plus 1. Distribute, distribute, distribute. X will cancel out, so I'll have 3 times x plus 1. Minus 4x, x plus 1 equals x plus 1 cancels out, so I have 2x times x, which is 2x squared. X plus 3 minus 4x squared minus 4x equals 2x squared. Subtract 2x squared, subtract 2x squared. So that gives me negative 2x squared. And let's see, minus x plus 3, negative 2x squared. 3x minus 4x is minus x, and plus 3. Okay. And I'll multiply both sides by negative 1, just to make the leading coefficient positive. It's usually preferable that way to have a positive here. 2x squared plus x minus 3 equals 0. Okay, so quadratic formula time. X is negative b. Negative 1 plus or minus the square root of b squared is 1 minus 4 times a times c over 2a.
Mr. Holm?
Yes.
In the original test, you had it as 6x squared plus x minus 3.
Yeah, I'm noticing something's not right. So 3 over x minus 4 is 2x. See, x times x plus 1, 3 times x plus 1 minus 4x. 2x squared. Minus 6x squared, correct. This should be a minus 6, which makes this a positive 6. Okay.
Yes, sir. Okay, thank you.
So this is all messed up now. So try it again. So negative b, negative 1 plus or minus the square root of b squared is 1 minus 4 times a, which is 6, times c, which is negative 3. Okay, I think this is better. Over 2 times a, 2 times 6. Negative 1 plus or minus. Okay. And this is 4 times 6 times 3 is 72 plus 1, so 73 over 12. So obviously, a direct result of this is show all your work. I do give partial credit. You get all the work. You mess up somewhere. I very easily mess up. I did over here already. So make sure you show all your work. Okay.
Mr. Holm?
Yes.
Now in this problem, there's another similar problem in the same quiz, but in this problem here, how can you verify that it's a real solution as opposed to no real solution?
No real solution. You'd have a square root of a negative, and that doesn't happen here.
You mean a negative inside the root?
It was a double negative. Negative 4 times 6 times negative 3. That's 2 negatives. Yes. So it's all positive. Now, if this was a positive 3, then yeah, I would say no real solution. Because then it would be 1 minus whatever.
So when it's a negative number inside the square, it makes it a no solution?
No real solution, correct.
Okay, thank you.
Okay. All right, number 8. So 7 minus log base 2 of 11x plus 30 equals 5. minus log base 2 of 11x plus 30 equals 5. Subtract 7, negative log base 2 of 11x plus 30 equals negative 2. Multiply both sides by negative 1. Log base 2 of 11x plus 30 equals 2. Okay, we unscramble it, so to speak. Go like this and like this. So 2 squared equals 11x plus 30. 4 equals 11x plus 30. Subtract 30. Negative 26 equals 11x. Divide by 11. X equals negative 26 over 11. And it says give to 3 decimal places. So 2.364. Okay.
Dr. Hom, can you explain the log rule real quick, what you did up there with the log 2?
Okay, so in general, I'll just explain in general, log base b of x equals y. Whenever you get an equation like this, it means the base is b, you go across the equal sign for the exponent and you come back in for the result. So b to the y is equal to x, is the way it should be. Okay, so in this particular case, 2 to the second power is 11x plus 30. Okay.
Professor.
Somebody can I put all the exam questions back on Canvas? That's actually not possible. I can't send attachments easily on Canvas. You should theoretically already have it. Whoever asked it, you can send me an email. I maybe can send an email, but if I'm not really willing to do it for too many people. You should already have it though. And I didn't delete it or anything. My general rule has been to put it in the Canvas announcements. So if you look back at, right, so if you look back on all the Canvas announcements, they should still be there.
Professor.
Yes.
Okay, in that example there, if you go back a little, if you go back up a few steps, where it says log square, parentheses 11x plus 30 equals 2. Now the next step says 2 square, right?
Yes.
But since you're now putting the 11x plus 30 on the other side, does that become a negative?
It does not become a negative, no. Okay, so this raised to that is equal to this. So right here, log base b of x equals y means the same thing as b to the y power equals x. Don't change any signs.
Okay, so that could easily be 11x plus 30 equals, okay, equals 4.
Equals
okay.
4, yes. Once you get to here,
okay,
it's pretty straightforward. That should be easy. Subtract 30,
yes.
divide by 11.
Oh, okay, okay. Yes, thank you.
Okay. All right. 9, y equals log base 2 of x. Graph it. Okay, so unscramble it. 2 to the y equals x. Okay, so you start with the base, you go across the equal sign for the exponent, come back in for the result. Right, so I'll just make a little mini table. Here you should pick values of y, not x, because it's directly affected by the 2. So negative 2, negative 1, 0, 1, 2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. Okay, so quick graph. 1, 2, 3, 4. 1, 2, 1, 2, perhaps. Okay, 1/4 negative 2. 1/2 -1, 1, 0, 2, 1, 4, 2. So log functions generally look something like this. Okay, question 10. $9,000 equals 1,500, 1.013 to the 5x power. Okay, divide by 1,500, divide by 1,500. So 6 equals 1.013 raised to the 5x. Then take the natural log of both sides, ln. Once you do that, the 5x gets to come down in front. ln 6 equals 5x ln 1.013. And then to solve for x, just divide by 5 ln 1.013. Whoops. 5 ln 1.013. 5 ln 1.013. So 5's drop out, ln 1.013 drops out. So x is natural log of 6 over 5 natural log 1.013. And punch it in your calculator, 27.7443 it looks like. Okay. All right, one of your classmates put in the chat the previous exam, so thank you. And I think I've got everything caught up here for the first test. Okay, so anything else in the first test? Otherwise, we can go to the second test or any other test if nobody else has anything. I know the first test was a real long time ago. Okay, I think I've caught up. It's hard for me to read the chat, and so if I missed your question, ask again. Yeah, I think I've caught up. So anybody else, please? Any questions? I've got nothing. I've got no lecture. So when you stop, I stop. Okay, so any other tests? Any other questions? Please. You can have all the previous formula sheets, and if you want to add to them, you can do that. That's no problem. Also. Anybody else, please?
Exam 2, number 2, question number 2.
Exam 2, number 2. Okay. I'm assuming we're done with test 1, so I'm going to put it away, sort of. Test 2, number 2. If you want to earn 10% annual simple interest on an investment, how much should you pay for a note that would be worth $20,000 after 7 years? Okay. So S is P 1 plus RT, using that formula. It'll be worth $20,000. So $20,000 goes here. Okay. You're not investing $20,000, it'll be worth $20,000. So that's the S by the formula. In 7 years, 10%. So 1 plus the rate was 10%, so that's 0.10. And 7 years is 7. So 20,000 is P times 1. 7 times 0.1 is 0.7, so 1.7. Divide by 1.7. Okay, and if it's money, money should always be rounded to the nearest penny. So I'll just peek at my answer. 11,764.71, it looks like.
Professor Hall.
So you multiply 0.10 by 7.
0.10 times 7 is 0.7, and then I add it to 1, it's 1.7.
Professor Hom,
Yes.
in this particular question, can you not use S equal to P in parentheses 1 plus I and close parentheses power of n?
1 plus I to the n, that would be for compound interest, which is not this case. Okay.
I see.
It says simple interest. So it's a different
Simple interest, okay.
Yeah, it's not compounded interest.
So simple interest, you use this formula. If it's
Simple
compound,
interest, you're using this one and this one, or any of these are equivalent.
are you
This
also
one is
going to
compound.
provide that in the exam? Or
I'll provide them, but you can certainly put it on your cheat sheet if you wish.
thank you.
Okay, and let's see. Number 8 was asked for. Okay, so $300,000 is invested in an annuity that earns 8% compounded quarterly. Okay, so let me write the data down. 300,000 invested, and it says 8% compounded quarterly. 8% quarterly. What payments will it provide at the end of each quarter for the next 5 years? Okay, so the interest rate per period is 8% is 0.08, but I have to divide it by 4 because it says quarterly, so that makes it 0.02. And then N, the total number of periods. So they said it was 5 years. Quarterly is 4 times a year. So 5 times 4, which is 20. And I'm going to be plugging into this formula, it looks like. Okay, so 300,000 equals R 1 minus 1.02 to the negative 20 divided by 0.02. Okay, so this is present value of an annuity. That's this one here. Okay. Now, during that final exam, if you pick the wrong formula, I'll give you partial credit. Just go as far as you can. Okay. Or if you make an arithmetic mistake, I'll give you partial credit. The worst thing to do, again, is to put nothing. If you put nothing, I have to give you nothing. But, you know, make a mistake, join the club. I make mistakes all the time, as you can see right over here, right? Okay, and all throughout this course, you've seen me mess up over and over and over, right? So make sure you put something so I can give you partial credit. Okay, and I'll just peek back at my notes, save time. This mess here came out to be about 16.35. Okay. And I don't want to take up class time just for punching in the calculator, so hopefully you get that. Okay, then I just divide both sides by that 16.35. So R is 300,000 divided by 16.35, etc. And again, I'll just peek at my notes. What did it come out to be? $18,347.02. So that's what we have for that one, it looks like. Okay, and I think I've caught up in the chat for now.
Can you do number 9, Professor Hom?
Same test?
Yes.
Okay, number 9.
Thank you.
Number 9, a debt of $50,000 to be amortized with 10 equal semi-annual payments. If the interest rate is 4% compounded semi-annually, what is the size of each payment? Okay. So number 9. Oh, I'll go ahead and disclose this right now. I will not ask you question 10. That takes up too much of your time to do the table. Okay, so don't worry about that. There's not enough time for that. Okay, so for test 2, I will not ask you number 10 to make the schedule. Does that help you guys? Okay, I mean, that itself takes you 15, 20 minutes, and that's not fair to you guys. Okay, number 9. Okay, so let's see, important information. The debt is 50,000. Okay. They already told me N is 10. Okay. So it's, the N is already 10. 10 equals semi-annual payments. So I don't have to multiply by 2 or whatever. I do have to take the interest rate and divide that by 2 because it says compounded semi-annually. So the I is 0.04 divided by 2, which is 0.02. Okay, so we're asking for the size of each payment. So it's pretty much the same formula. Okay, so using this formula. So 50,000 goes here. We're solving for R, and I plug in the I and the N. Okay, so here we go. 50,000 equals R. 1 minus 1 plus I, so 1.02 to the negative N, so that's negative 10. And divide that by I, which is 0.02 by formula. So R bracket 1 minus 1 plus I to the negative N divided by I. This one. Make sure you have it on your cheat sheet. If it's already there from test 2, then you're good. If you lost it or whatever, just write another one again. Okay, and this stuff comes out to be about 8.98 times R. So just divide by 8.98 and you find R. So R is 50,000 divided by 8.98. And squiggly equal, let's see, 5566.33. Okay, and if anybody wants me to ask a question about the calculator, you can, on how do I type it in and so on. Sorry, my paper's starting to curl, so I'm going to uncurl it.
Could you type that, please?
Okay, which one? This one here?
Yes.
Okay, so let's see. Parentheses, 1 minus 1.02. Okay, on my calculator, this is how you get an exponent. This one here. Okay, if you have a regular scientific calculator, it's y to the x. That's this one. Get the exponent. And 1.02 raised to the negative 10. Negative 10. Okay, so on my calculator, the negative button is here. If you have this kind of calculator, it's a plus or minus. And you actually have to type the plus or minus after the number. So that means you folks have to hit 10 and then hit this symbol, and then the negative would pop up. Okay, so there's 1 minus 1.02 to the negative 10. And I'm supposed to divide it by what? 0.02. So divided by 0.02. You can see that. 1 minus 1.02 to negative 10 divided by 0.02. 8.98, blah, 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 blah. Okay, and then I want 50,000 divided by that answer. So my calculator has an answer button down here. So if you have an answer button, just hit 50,000 divided by answer. If you don't have an answer button, then sorry, you have to write down the number. And then, so you folks would, for greatest accuracy, you have to go 50,000 divided by 8.9825050006, blah, 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 blah. Looks like I don't have the division symbol there. Okay. 5566.33 rounded off.
I got it. Thank you.
Okay. All right. You're welcome. All right. Okay. How are we doing on time? 6:15? I think we're okay. Depends. Okay. What else, please? I think I'm caught up with test 2. Okay, and I don't hear anything else. If you want to go to test 3, we can, or any other test. Okay. Test 3 or 4 or 5. Anybody, please? If I miss your question in the chat, ask again or unmute yourself. Okay. It's hard for me to teach and do this and look at the chat at the same time and catch up. So if I miss your question, ask again. Whoops. I did something wrong here. case you don't already know, I'm not an expert on Zoom. But some of you probably know more about Zoom than I know. Okay, exam 3, number 3. Okay, so we're on to test 3 of X-Lite. Test 3, number 3. Give the average rate of change of the function f of x equals x squared between 2 and 2.01. Then give an estimate for the instantaneous rate of change of the function at x equals 1. Okay, so f of x equals x squared. Average rate of change from 2 to 2.01. Okay, these are both x values. Okay, so in other words, you go 2 comma something, 2.01 comma something. Okay, how do I find the somethings? I square it. 2 squared, I don't need a calculator for that. It's 4. 2.01, I do need a calculator to square that. So 2.01 squared, 4.0401, 4.0401. Okay, so from 2 to 2.01, those are both x values. I have to find the y values. Okay, and average rate of change is now just the slope of the line joining these two. Okay, so average rate of change is really slow. So y2 minus y1 divided by x2 minus x1. So 4.0401 minus 4 divided by 2.01 minus 2. Okay, and can I do that in my head? 0.0401 divided by 0.01, which is 4.01. Okay, and what's a nice number that this is near? Well, 4. Okay, so it says estimate the instantaneous rate of change. So estimate instantaneous rate of change 4. Okay, and by the way, this problem's finished, but you can actually prove that now that you know derivatives. So if it asks for the instantaneous rate of change, you know that means derivative. Okay, so let me just draw a line here, meaning I'm finished with the problem, but I'll dig deeper. So what's the derivative of x squared? 2x, right? So f prime of x is 2x, and you're finding the estimate for the rate of change at 2, so I plug in 2. So 2 times 2, which is 4, and that matches what we have here. But notice doing this is way easier, right? The derivative was much easier than doing all of this stuff, obviously, right? So there's that one. Okay, question 2. Okay, so you're given this function. F of x is a piecewise defined function. X minus 5 if x is less than or equal to 2. And then 3x minus 10 if x is greater than 2. Okay, so is the function continuous or not continuous at x equals 2? All right, so the easiest way to explain it is plug in 2 to this, plug in 2 to this. If you get the same value, it's continuous. If you don't get the same value, it's not continuous. Okay, so in order to work this problem out, just put a 2 right there and put a 2 right there. So 2 minus 5 is negative 3. And 3 times 2 minus 10 is 6 minus 10, which is negative 4. And you can see they're not equal. Not equal. So f is not continuous at x equals 2. Okay, but let's pretend this came out to be negative 3. This also came out to be negative 3. Then we would say, yes, the function is continuous at x equals 2. Okay. All right, I see in the chat some questions from exam 4, but as long as I've got exam 3 here. Anybody else with exam 3 questions, please? Okay, exam 4, question 1 and question 4. Okay. Test 4, number 1. Okay, reminder, on Thursday, no question and answer. We'll go straight to the final exam. So any questions and answers has to be now, or that's it. Okay, exam 4, number 1. I can open this up. Okay, find the critical values of blah, 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 and then use the Sine chart to determine maxima and minima. Okay, so how do you do that? F of x is x cubed plus 3x squared. Okay, so find maxima and minima. So I take the derivative, 3x squared plus 6x, and I set it equal to 0. So let's see, what can I factor out? 3x, x plus 2 equals 0. Okay, so that means x equals 0 or x equals negative 2. Okay, those are my critical values. And let's translate that to points. 0 is easy to plug in. What do you get when you plug in 0? 0. 0 cubed is 0. 0 squared is 0. 3 times 0 is 0. 0 plus 0. Okay. And negative 2 is a little bit harder. F of negative 2. So negative 2 cubed, negative 8, plus 3 times negative 2 squared. Negative 2 squared is 4. 3 times 4 is 12. So 4. So negative 2 comma 4. Okay, then next thing I do is a sine chart. So the derivative came out to be this thing, right?
Professor,
Yes, question.
what is in the end down the bottom? F negative 1?
F of negative 2 right here. That should be a negative 2.
Oh, okay. Sorry. Got it.
Okay. Let me double check if I did that right. Okay. So sine chart. The derivative came out to be 3x times x plus 2. Negative 2, 0. Okay, so pick something here, here, and here. So negative 3. Put something here, negative 1. Something here is 1. Okay, plug in 3 times negative 3 is a negative. Negative 3 plus 2 is negative 1. It's a negative. So negative times a negative is a positive. 3 times negative 1, negative. Negative 1 plus 2 is a positive. So negative times a positive is a negative. Plug in 1, everything's positive, right? 3 times 1 is positive. 1 plus 2 is positive. Positive times positive is positive. Okay, positive first derivative, increasing. Negative first derivative, decreasing. Positive, increasing. Okay, so it's asking for max and min. At negative 2, the graph goes up, then it goes down. That must mean a maximum. So negative 2, 4 is a max. At 0, we go down the roller coaster, then we go up the roller coaster. That must mean we have a minimum. So 0, 0 is a minimum. Okay. So that's that. Okay. And then number 4, find the absolute maxima and minima, blah, 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 on the interval from negative 2 to 2. So for sure, you have to plug in negative 2 and 2, and then you also plug in the critical values. Okay. So we have a closed interval. Remember, the graph might look something like this, right? And you might have a maximum, minimum at the end point, not because the derivative is 0, right? It's just because it's an end point. So we will find the critical values. That means where the slope is 0, right? And we have to test the endpoints. And then whichever of those is the highest, that's going to be the maximum, and whichever is the lowest, that'll be the minimum. Okay. So let's try that. So for test 4, question 4, f of x is equal to x cubed plus x squared minus x plus 1. Okay. Whoops. My chat got too big. I'm trying to make it smaller, but I don't seem to be able to do it. There we go. All right. And let me write down the interval. It goes from -2 to 2. Okay. So let's take the derivative. 3x squared plus 2x minus 1. Set that equal to 0. Factorize. 3x x. 1 is 1 and 1. And let's see. Plus minus. Is that right? Okay. So what makes that 0? 1/3. What makes this 0? -1. Okay, so I'm going to plug in 1/3, -1, -2, and 2. So here we go. F of -2. Plug in -2. -2 cubed, -8. -2 squared is 4. Minus a -2 is +2, +1, so -1. And let me plug in the other endpoint, +2. So let's see, 2 cubed is 8. 2 squared is 4. Minus 2 plus 1. 11. Okay, now I plug in the critical values. So F of 1/3, that's not very fun. Let's see, 1/3 cubed, 1/3 times 1/3 times 1/3, 4/27. 1/3 squared is 1/9. Minus 1/3 plus 1. So a good common denominator is 27. 1 plus 3. Let's see, minus 9 plus 27. And that came out to be 22/27, I think it was. Okay. Then the last number I have to plug in is -1. F of -1. Okay, -1 cubed is -1. -1 squared is 1. Minus a -1 is +1 plus 1, so 2. Okay, so I look at these 4 numbers and pick the highest and the lowest. 22/27, that's a fraction, so that's not, so that looks like the smallest and it looks like the biggest, right? So absolute minimum is at -2, -1, looks like. And the absolute maximum looks like it's 211, like that. Okay.
Professor Hong.
Yes.
How can you get -9 when you plug in 1/3?
This -9 right here?
Yes.
Common denominator is 27, so I multiply top and bottom by 9. 3 times 9 is 27. -1 times 9 is -9. Is that what you mean?
Oh, you multiply with -1/3?
I'm multiplying the numerator and denominator by 9 here. From arithmetic, I need a common denominator. That's what I did.
Thank you.
Okay, welcome. Let's see, is the equation of the tangent line to the curve the same thing as a point slope form? I mean, you're going to leave your answer in point slope form. If to formally answer your questions, they're not the same thing. They're not one and the same. But you can write the equation of the tangent line that's not in point slope form. But if you leave it in point slope form, that's good enough for me.
Professor, I'm just referring to the question number 9 in the exam 4. 9?
Yeah. You want me to just do that later?
No, it's okay. I'm just referring to the second part of the question in number 9. I mean, not the second part, sorry, the equation of the tangent line. After derivative.
It came out to be y equals x.
Mm-hmm.
But if you left it as, you know, that was the most simplified form because it was so easy. But if you leave it like that, that's okay. But I looked at it and said, you know, if I subtract 0, you can just throw it out. If I multiply by 1, you don't really need that either. So,
But why did we use the point slope form?
that's how you come up with the equation of the tangent line.
Okay.
Yeah. Maybe I'll just do this problem. But somebody asked for number 3.
Professor, sorry. Before you start number 3, can you go back to the last one real quick?
Okay.
So how do you know what the absolute minimum and absolute maximum is without doing the chart?
How do I know which is the absolute maximum and minimum? Yeah, just look at these 4 numbers. These 4 numbers, which is the lowest? -1. Which is the highest?
Okay.
11. So that gives me max and min. Okay.
Got it. Thank you.
Number 3, find maximum, minimum, points of inflection. F of x equals x cubed plus 3x. Okay, so f prime of x is 3x squared plus 3. And I noticed that's always greater than 0, right? There's no way this is going to be 0. There's no way it's going to be negative. When you square something, it can't be negative. Multiplied by 3, it can't be negative. Then you add 3, it's definitely positive. So f is always increasing. Formula, I say it's increasing from negative infinity to infinity. So that means automatically there's no max or min. To have a maximum min, the derivative has to be 0, but it can't happen here. So that part's already finished. Okay, I can do the second derivative. 6x. Set that equal to 0. That's easy. X equals 0. So the ordered pair is 0, 0. Quick sine chart. That's also very easy. The second derivative is 6x. If I plug in negative, it's negative. If I plug in a positive, it's positive. So concave down, concave up. So the function is concave down from negative infinity to 0. The function is concave up from 0 to infinity, which means the origin is an inflection point. So I'm ready for the graph, which is not really that much of a graph, but what it is. Inflection point, always increasing. First, it's concave down. After that, it's concave up. There we go. Okay, why don't I go ahead and just do problem 9 from test 4. Write the equation of the tangent line to the curve at x equals 0. Okay. Test 4, number 9. Okay, and I didn't delete any of the videos, so you can always go back and look over the videos for the solutions too. Okay, so at x equals 0, and what do you get when you plug in 0? 0. 0 times anything is 0. Okay, so first I find a derivative. This is the product rule. First function, second function. Okay. Remember, you can have the product rule and quotient rule and chain rule. Put all those on your cheat sheet. So product rule, first function times the derivative of the second. What was the derivative of e to the x? E to the x. Plus the second function, e to the x, times the derivative of the first function. What was the derivative of x? 1, which means you don't really have to write it. Then I plug in 0. 0 here means that's 0. e to the 0 is 1. So my slope is 1. Right, plug it into y minus y1 equals m times x minus x1. You can put this on your cheat sheet. If you already have it, great. If you forgot it, put it now. Y minus y1, 0, equals m1 times x minus x1, which is also 0. Okay. And, you know, I wrote it as y equals x because if you subtract nothing, forget that, multiplying by 1 means you can forget it. So that's the easiest way to write that pretty much. Okay.
Professor, could you explain the wording, the language? Like you're asking for the creation of the tangent line. Like, how would you graph it?
To graph this function is not that easy. Okay. There's a lot of work involved, but the tangent line is y equals x. So whatever this graph looks like, right here, that's the slope. Okay. So maybe the graph looks something like this. I'm just making it up. Okay. But it's going to be a lot more work to actually sketch the graph of this. It's possible, but it's too much work for now.
Okay. Thank you.
All right, you're welcome. Okay, I think I've caught up. How are we doing on time? 6:30.
Mr. Holmes.
37. Okay, anybody else, please?
Yes, Professor.
Yes,
Professor.
Yes, I hear you.
In this example here, how come it's y equals x as opposed to y equals 1x minus 1?
It's not minus 1. The point was 0, 0. It's the origin. You're given x equals 0. I plug in, that gives me y equals 0. Put a 0 here and a 0 here. 0 times anything is 0. You can't get any better than plugging in zeros. So 0 there, that's x1, that's y1, and that's m.
But are you multiplying there the 1 times x and then minus 1?
I'm changing x minus 0 to x. Anything minus 0 is the same thing. And then 1 times x is just x.
So the y equals 1 would be wrong?
Y equals 1 is not the same as y equals x. That's definitely wrong.
So how do you cancel out the 1 from that equation there?
Oh, okay. Are you okay with losing the 0 here? Pretend the 0 is not there.
Okay.
Subtract 0. So it's 1x. You agree?
Yes.
Okay. What's the easiest way to say 1x?
Okay, x.
That's x.
Okay. Okay, I understand. Okay.
And likewise, y minus nothing, you know, y minus nothing is y. Okay, anybody, I think I've caught up. Anybody else, please? Either in the chat or unmute yourselves. We still
Professor Holm.
Yes.
You know, on the top of that equation, x e power of x plus ex. Yes. So when the e to the power of x is equal to 1.
I'm sorry, e to the x is what?
Is it 1? Because
you put... No, definitely not. It's an expression all by itself.
So it's not EU?
It's e to the x times 1 by the product rule. This was part of the product root. First times the root of the second, plus second times the root of the first. Am I answering a question or no?
No, I don't
Otherwise,
get it.
I'm not sure what you're asking.
Yeah, I don't understand how did you get times.
This is from the product root.
Mm-hmm.
Mm-hmm. First function times the root of the second, plus the second function times the root of the first. Fg prime is Fg prime plus Gf prime. Product rule. That's what I was doing.
Okay. Got it.
Okay. Okay, question 10. Give the derivative of whatever. Okay. Y equals natural log of x over x. Find the derivative. So this is the quotient root, right? So the bottom times the derivative of the top. What's the derivative of ln x? 1 over x. Minus the top times the derivative of the bottom. What's the derivative of x? 1. All over the square of the denominator. And then clean it up. X times 1 over x is just 1. The x cancels out. 1 minus ln x over x squared. And that's pretty much about it. Okay, anybody else? Any more, please? Okay, if I don't hear anything or I don't see any chat, we're done, folks. Nothing else?
Yeah, I'm okay. Thank you.
Okay. All right, I don't see anything or I don't hear anything, so we can adjourn. So take your 5 tests, go over them, review them. Don't look at the book. Don't look at your homework. Not necessary. Get your formula sheets. If you want to put something on the formula sheets extra, that's fine. You can bring all the formula sheets in. That's perfectly fine. So right at the start of class, we'll go straight to the final exam from 5:40 to 6:55. So you have an hour and 15 minutes to do 15 questions, okay? And that's pretty much about it. I'll still be available by email. In the meantime, if you want to email me, that's fine. Okay. All right, that'll do it for tonight, folks. So have a good night, and we'll see everybody for the final exam on Thursday. All right, thank you, everybody. Okay, bye.
Thank you.
Good night.
Thank you, Professor.
Good night. Thank you.
Good night.